So we're going to, in the next couple of videos, look at something called linear kinematics. And it involves a process called differentiation. So this video sort of combines the two. So this graph shows you, equation shows you what we call displacement, or I suppose distance traveled, and how it relates to time. So what the equation is saying is that if you squared the amount of time that, say, a car's been traveling, multiplied it by 3, added the amount again, the amount that it had time of it been traveling for, and take away 2, that would tell you the distance or the displacement of the object. Now this equation has been totally made up, but it shows a relationship between time and displacement, which is important for kinematics. And what if I wanted to work out the velocity of the object in relation to time? We know that in distance time graphs, the velocity is the gradient of the distance time graph. So can I show a gradient equation if I've got how displacement relates to time? Well, yes, you can. You can do it by differentiation. So this differentiation works for anything whenever you have to do differentiation. But the first thing we've got to do is multiply any powers, so any terms, by the power that's there. So for instance, this one by here is to the power of 2. So I'm going to multiply the whole 3t squared by 2. And I'm going to end up with 3 times 2t squared, giving us 6t to the 2 squared. The next thing I do is take off 1 from the power. So I multiply the number in front by the power, and then take off 1 from the power. And we know that 6t to the 1 is just simply 6t. And I move on then to the next term. Well, multiplying, remember there's an invisible 1 here, so multiplying the number in front of the t by the power is simply 1 times 1. So not going to make any difference. But I'm going to take 1 off the power, and as I said, remember there's an invisible 1, so 1 take away 1 gives me 2t to the 0, and as we know, anything to the power of 0 is simply 1, so I'll change that to a 1. I move on to the next term, and now with any number on the end, you just simply remove that. So this now is an equation which actually shows how time relates to velocity. So if I wanted to calculate the velocity at that point, it would be multiplying the time by 6 and adding 1. I can even go a step further then to work out the gradient of that curve by working out in order to work out the acceleration, because we know that acceleration is the gradient of a velocity time graph. So again, I shouldn't say t by here, so I should say 6, but I'm going to multiply the 6 by the power, which is a 1, giving me a 6 in front. I'm going to take away 1 from the power, which will be 1 take away 1, giving me a 0. And as I said in the last bit, the t to the 0 is 1, so it's going to give me 6 times 1, which is 6, and then I simply remove the number 1 at the end. So the gradient of the velocity time relationship is simply 6. So we've moved up by differentiating each equation. We've moved up from how time relates to distance, time relates to velocity, and then time, or in this case a fixed quantity, relates to acceleration. So by differentiating each equation, I can move up to work out respectively velocity and acceleration in relation to time. And this differentiation works for anything. So remember, with differentiation, multiply the number in front by the power and take away 1 off the power. Do that for every one of the terms and remove any number that's just sitting on its end at the end.